Okay.
You guys can hear us, right? Everything's good?
Great. Mag, you're starting us off.
Sure. All right, we'll get started. Thanks everybody for coming. I know it's 9 a.m. A lot of respect for that. So I know everyone came here to talk about how to become a Cosmos MEV searcher, but in fact, we are unfortunately going to rug you and talk about something different, at least temporarily. If you stick around until the end, I will talk about how to become a Cosmos MEV searcher. It's a lot simpler than you think. But instead, we want to talk about something different, which is how do we incentivize relayers? So in Cosmos and in IBC more generally, we require relayers to transmit packets between chains, right? The problem is that those relayers are not incentivized, and it's not a scalable system. And does anyone here run a relayer by chance?
Or has in the past. Has anyone run a searching bot? Cool. Okay.
Okay. They're actually very related, and so we'll talk about how they're related. But I'm going to pass it off to Sam to start talking about it.
Cool. Okay, so just a little background on like where we're at with the current relaying ecosystem. Sorry, I have to like crane my neck all the way over to see this. So right now, relayers are not incentivized. For anyone who isn't aware, relayers are the entities that ferry packets between different Cosmos chains. They're the kind of backbone of IBC. Right now, they're not incentivized. The reason that they're not incentivized was intentional, even though it's something that people often kind of identify as a weakness in IBC, but it was intentional because when the IBC protocol was being built, it wasn't entirely clear what the business model of the different chains or entities involved would be, and so kind of enshrining an incentivization scheme seemed premature. So the idea was to kind of layer on an incentive model afterwards, or potentially have a variety of different incentive models. But right now, relayers aren't really incentivized. There's no reward for being fast or reliable. There's no redundancy in the system really, and there's spotty coverage for different connections between different chains. Some chains don't have any connections with one another, and right now, I think this is you. Okay, I'll go into a little bit more about the like what is actually working today, how it works today, but.
Yeah, so like just to talk about how it works today. So oftentimes validators will run relayers, right? And so what validators do when they do that is they run basically free software that monitors one chain, looks for packets that are emitted by IBC transactions, takes those packets, moves them to the other chain, creates a transaction out of them, and pays for that transaction. The relayer does, right? So you're, as a relayer, paying for the user's transaction. They're essentially getting a free transaction. And if you replicate that over and over and over again, these relayers run out of money, right? They are using their own funds to pay for user packets. And the big question is, well, why do they do that, right? It doesn't make any sense. And so like we're gonna talk about like the reasons why they do that right now. There's a variety of reasons, but it's definitely a consistent problem. So I wanted to ask sort of the question, like, what are the biggest issues with relaying? Imperator, maybe if you have some ideas, this is also, can be interactive.
Yeah, I think what you said, it's mostly around like incentivization. Like it's really hard to run a relayer if you're not incentivized. Mostly like as a validator, we are mostly working with foundation and core teams to give us like a delegation for like running a relayer. So that's the main pain point.
Yeah, it makes a lot of sense. I think also when, and some people here might go to the Neutron Hacker Lounge later, but when Neutron launched, and I think just recently, there was a ton of spam IBC traffic between Neutron and the hub, and that emptied the wallets of some relayers that were trying to like monitor that traffic. And so it's not a DOS protected system, right? It's not strong against an attack like that, for example. And so people can take advantage of the relayers.
Yeah, so right now, relayers, the entities that are running relayers, like Imperator was saying, they either get a foundation delegation, so basically a service contract, or they use it as kind of an advertisement, a loss leader to solicit retail delegations. And it does work, at least in the current system, but our kind of thesis here is it's not scalable, both from a kind of, from the perspective of the kind of coordination costs on the foundation side, and we'll get into some other reasons why we think like as the IBC network gets used, it's just not going to really work. It's also not really transparent what's going on. So when a new chain enters the network, they have to kind of like ask around, how do you get relayers? How does this work? They need to find relayers. They need to there's no wayfinding here, and it's essential to actually get liquidity for your token. And as a user or as an application developer, the IBC packet relay quality varies substantially depending on what connection or channel you're on. So it's a little bit difficult to kind of account for that because the network's unreliable. So, yeah.
So like just to talk about the size of the relayer market, I mean, this is essentially what's happening, right? Like these chains are just like putting money into the relayers, like trying to incentivize them to relay packets, but it's a money losing business. And so they have to pay for the gas fees and they have to pay for the operation cost. We talked to some different relayers and we found out some deals that they did. And then we extrapolated that out. We found out there's approximately about $7 to $10 million worth of these deals being struck where foundations are paying for relayers and saying, hey, run a relayer for us. Some of the notable names here might be Imperator, Strangelove, Notional, Crypto Crew runs some crazy ass relayers, check it out sometime. But there's like a couple of these companies that are using this as a business, right? So we found out that like in terms of cost, running a relayer is about like 30 to 60K a month if you have like a big relayer operation across many different chains. That's what you're spending in gas fees. You'd be surprised because everyone says Cosmos gas fees are free, but it adds up. And then like approximately on these deals, there's like 25 to 50% profit. So they're charging that on top to foundations. And then foundations will pay, either via delegation or sometimes just like a SaaS contract. Like they'll just, give them the money. Yeah. Switch back to you.
Yeah, so it gets worse. Right now, it's kind of the bottom of the bear market, but and so basically what we have is chains have empty blocks. The slide previous, the dominant cost for the relayer is actually infrastructure costs, so it's like AWS or whatever server setup they have. Those costs are largely fixed, so you can project out, okay, I'm going to run relays on this number of channels, this number of connections, and I have some sense of like the number of servers I want. And then from a network perspective, like the number of connections is n squared with the number of chains, so that's kind of the scaling factor. In the bull market, this gets substantially worse. So once you have full blocks, the fees can start to dominate the equation. The only chains that have had full blocks in Cosmos have basically been Terra and Osmosis more recently. Once you have full blocks, now fees dominate the kind of, they create this variable cost, so it's much harder to project. And the pricing is based on the congestion pricing of the network. So these service contracts are going to get much funkier if that's kind of how we're moving forward. And Yeah, I mean, just the entire kind of calculus of running a relayer, how you're building a business around that is going to change completely.
Cool. I want to stop for a second. Any sort of questions about this? Yeah, Moritz.
Just for my understanding, if you run a relayer, you run two nodes, right, on both sides,
Yeah.
and then the relayer somewhere in between. So that's also what covers your infrastructure for relaying between two chains, right?
Yeah, exactly.
Okay.
You have to pay for the infrastructure of running 2 full nodes,
Yeah,
and then you have to pay for the gas fees
yeah,
of
exactly.
getting the transactions up. Yeah. Any other questions about this kind of stuff?
Can you
Yeah.
go one slide back?
Sure.
Yeah, can you quickly run through roughly the profit margin calculation? Like just on a high level? I didn't understand whether 50%.
Yeah, so we got this out of 2 people, but roughly the relayer companies will charge the foundation the base gas costs plus 25 to 50% on top of
Oh,
that.
that's on top.
Yeah, so they'll charge, like in this case, another 15 to 30K just for I guess, yeah, to like cover the infrastructure and their operations and stuff like that. It's decent business,
Yeah, love that.
Could pay for a couple conferences on
So in
it.
the bull market, it's more expensive or less expensive?
It's going to be much more expensive.
It's
Yeah.
much more, so it's more expensive because you have to pay the infrastructure costs, but now the cost of the tokens actually becomes the dominant part of the breakdown. And it's a variable cost. It's much more difficult to project out what your costs are. So it's more challenging from both of those perspectives.
Cool. So we're going to transition to how can we incentivize relayers for the long term, right? So we all want IBC to grow. Every chain, well, not every chain, but most Cosmos chains use IBC. Relayers are the backbone of that system, right? And relayers have gotten a lot better. I think early on, it was TBD if your packet would ever make it. Now it's pretty good. Like if you use Osmosis, if you use Stride, if you use, Axelar, you'll find that packets get relayed quite quickly, like within 5 to 20 seconds, and that's kind of a miracle because most of it is not incentivized, right? No one's a lot of relaying is hobbyists who are just excited about IBC and want to support the ecosystem, and we're not sure that that's going to last, especially if it costs hundreds of thousands of dollars in a bull market. So how do we incentivize relayers going forward for the next 10, 20, etc. years?
So there is a new ICS standard. ICS is the interchain standards, is the IBC standard that is going to ship in a upcoming release. It's been in development for a long time, called ICS 29 for relayer incentivization. The way that this works is a user on chain A can attach a secondary fee that the relayer is eligible to claim if they relay the packet and then relay an acknowledgement that says that they were the one to relay. The end product of this, is, if chains adopt it, is that the first relayer will be the one that claims the IBC packet. So it will create a latency game. It's not totally clear what the adoption curve is going to look like here, or who wants this, or how they're going to interact with it. We've done a little bit of initial research to try to understand this. One of the issues is that it hurts UX. So if you're a chain that is really focused on adoption, layering on another fee for the user is going to be challenging. So potentially just the foundation delegation is the way to go. So we've been trying to think through some of these UX issues. We've been very, very focused on cross-chain UX and just how this is going to play out, how we can make this as easy as possible for deploying new applications and really making sure that kind of cross-chain flows work as simply as possible. We think that MEV can play a role here. This latency game will end up becoming a kind of form of MEV. So if you're relaying today, you will be engaging in MEV in the future, whether you like it or not. And yeah, we're starting to think about how to decentralize the kind of way that relayers are contracted and what those service contracts start to look like. We're taking this very slowly and trying to kind of understand how the market is evolving, but we're going to share a couple of these ideas.
Yeah, and yeah, what's up?
So you said in the future where if you run a relayer, you have to deal with MEV whether you like it or not. How do you mean, how does that work like? Is it in the case that MEV is going to be the way to incentivize this, or is it going to be that in any case?
So just with the ICS 29 standard, if two chains deploy this and you're relaying on that chain, the first relayer to successfully submit the packet will be the one that gets the reward. So this is a latency game. It's an ordering. Now relayers are concerned with ordering of packets, and it will, that kind of definitionally is a form of MEV.
There's also something a little bit scary, which is that, what's up, Dan? If you, so like, let's say there's a packet with a big reward on it, right? Somebody fat fingers puts 100 atom as a reward on a packet. All the relayers fight to transmit it. Let's say Imperator wins, right? And so they should have gotten that reward. They are not guaranteed to get that reward because the validator can wrap their own version of the transaction on that packet and submit it and censor Imperator. So the relayer has done all the work of getting the packet to the chain, but then the validator who actually needs to put it in their block can say, actually, I'm going to take that packet, I'm going to wrap it with my own transaction, and then I get the reward, right? And so they're in a world where IBC becomes valuable, which we're all hoping, these will become real problems, right? Because there will be big fees on these packets. Also, these packets may not just be like sending money, it might be swapping, right? With ICA or ICQ and stuff like that, and Oracle updates and things that have a lot of MEV associated with them, in which case validators, relayers, there's gonna be like a very competitive market around trying to background these opportunities and trying to capture the MEV that comes out of them. And what we've seen, in other ecosystems is we have to create fair systems around that.
I think this is.
Oh, you want me to switch side? Yeah. Oh yeah. So I guess we just talked about this, but relayer will see user packets and then uncover it. There's actually MEV there. So that would be the case in which there's DeFi, any kind of swaps, Oracle updates, things like that. And because relayer is allowed to add arbitrary messages to the end of user packets when they create a transaction, they can do anything. They can sandwich it, they can backrun it, they can front run it, they can do anything and you wouldn't really be able to tell necessarily. And because it's a permissionless system, there's no prevention from these kinds of things, right? So I think one very profitable thing that somebody could do in the future is if any one of these cross-chain dexes or things launch like Catalyst or something like that, you could create like a interchain MEV-aware relayer that just grabs these packets and is intelligent about this. And we're actually building one right now. We're building a relayer that does backrunning, which is like harmless arbitrage.
Yeah, I can tell you that the IBC team is not very well versed with MEV, so they have not really thought about validators stealing relay fees. Thankfully, we are thinking about it, and we think we have some fixes. This is still very exploratory, like how we think, where we think we could go with relaying in the future. So one thing in our kind of initial discussions with relayers and foundations is some desire to have redundancy and a degree of fairness. So right now, with these foundation contracts. Typically there'll be kind of overlapping coverage for different channels, and there may be two relayers relaying on a channel, but only one relayer, but basically one relayer has a slight latency advantage, so they'll win every single packet, and you actually can't see the second relayer that's relaying on that channel. But that relayer is important, because if the fastest relayer goes down, they're there to make sure that the packets are delivered. So being able to have some kind of system to either detect that the fallback relayer is there and compensate them accordingly is going to be important. So you could either kind of switch off which relayer is kind of eligible to get the packet in, or you can have some kind of like observable heartbeat that that kind of ensures that the relayer is delivering packets. So one thing that we're kind of focused on here is additional relayer accountability. So that's just like starts with this observability, and then kind of creating some kind of overlay and kind of intelligence about which relayers are actually relaying on which channels, and then you can start to incentivize that and create like SLAs that kind of correspond to that accountable system.
Any other questions so far?
Now, you were saying that relayers can like add any arbitrary data to packets?
They can add additional messages to the transaction.
Messages?
Yeah, because they take the packet and then they make a transaction out of it, including that packet, which they turn into a message, and then they can add other messages.
Okay.
So for example, if the packet that they transmitted was a big swap, they could add a background.
No, okay. That misunderstood.
Maybe just back to that one more time. So yeah, like the idea here is like if you think about a Cosmos chain, the reason that MEV works on a Cosmos chain is because the validators get sort of like a monopoly on the block space for one block, right? Like the validator gets to decide that they can create that block, and so they're basically, you have to work out the deal with them in terms of like MEV recapture and stuff. But because in relayers right now, everyone's fighting for the same exact thing, it would be like having a chain where all the validators are competing to submit the block first. But instead what you want is something where it's like each relayer can get a chance, and therefore they get the opportunity to recapture. And then if they miss it or something happens, it can just switch to somebody else. And that way, like, you would have more fair distribution of these rewards. And you could also get a sense of, well, it was your responsibility to relay this packet, you didn't do it, so we're going to switch off, and also like you're going to get penalized or slashed or something like that. It's a lot of text, wow. So like just thinking about what do people want out of IBC, right? We'll start slow. So on the left side, like what do protocols want? They just want to connect to IBC, right? You're a new chain, you know that you want to be connected to IBC because let's say you want liquidity from osmosis, like you want to make that as easy as possible. Ideally, you have like a website where you go and you're like, enter your chain ID, connect channels, and then like select from a drop-down list. Something as simple as that. As a foundation, if you're paying, you want to pay for quality, right? You want to pay for fast relaying, like guaranteed delivery times and things like that. You also wanted to make it easy to maintain what they call light clients, right? Or these the representations of other chains so that you can keep your connections open. You want one-to-many connections, right? So the ability to connect to as few places as possible to get as much like bang for your buck. So if you connect to osmosis, for example, you get to connect to a bunch of other chains that are connected to osmosis as well.
Long side, so I'll do this part. What do relayers want? So they want some reliable form of revenue, or at least like the payoff should be kind of commensurate with the effort that they're putting in. They want to be incentivized for their performance. the best relayers, the most kind of robust relayers, should get paid for that. And that doesn't necessarily mean the fastest relayer. You know, you may have the kind of the most resilient and redundant infrastructure, and that could be more beneficial for the network. They don't want to have to know everyone or necessarily run a node for everyone. It'd be nice if you could just be more selective and run the infrastructure that is most relevant for your core business. And of course, they want to be able to scale effectively.
I have two questions.
Yeah.
Regarding relais, can they decide to skip the packet when they see it, or they need to process it, basically they are compliant with it?
Yeah, so the relayer software, there's a couple different relayer softwares that are available today. And it's really dependent on what the software supports. Of course, if you modify the software, you can be selective or filter in any way you want. Some of the software is much more kind of rudimentary, so it's just going to relay on a single channel or a single packet type or something like that. But the sophistication of the software is going to really make it highly filterable, selectable, and our kind of contention here is that relayer software is really going to merge with searching infrastructure quite soon.
Okay. And the second question, how are the encrypted mempools like changing this like behavior of validators, maybe potentially like legal things or not?
Yeah, so encrypted mempool means that nobody can understand like what is inside the mempool. So like if you have let's say you have a packet coming from a non-encrypted chain to an encrypted mempool chain, people would still be able to understand what that packet is. And then once it gets put into a transaction, technically that transaction will be encrypted. So it's a good question. Like I think you'd be able to understand what the packet is, but I guess you wouldn't know. You wouldn't be able to see just from looking at the mempool that that packet's there.
Yeah. So encrypted mempools are typically thought of as kind of a user to chain flow, and IBC is typically thought of as a chain-to-chain flow. If you're going from a transparent chain to a transparent chain, and you're intermediating through like an encrypted channel, you can still kind of see the packet going in and then the packet coming out at the end. So it doesn't give you much help there. You could imagine some kind of like shielded pool that's doing like, you know, randomization, timing randomization or something on this side, like that could potentially help, but I don't know anyone who's building that. But it's certainly possible. And then once you get to multiple like shielded chains, like yes, the relaying between them will be kind of indistinguishable from other packet types.
Thank you.
More to a question?
I'm fine, thank you.
Cool. So I know we said we rugged you. You came here to learn how to be a MEV searcher, and then you just heard a bunch about relayers. And you're like, why did I listen to that? It is important. But on the other hand, we are going to talk about MEV searching. So people who, I know some people raised their hands about they were a MEV searcher before. Can you just explain a little bit? Maybe just raise your hand, what you've done, how it's been. Just curious. Don't share secrets. Yes.
In the early days of Osmosis, like real early days,
Yeah.
and also in my early days of programming, I built a MEV board, like on Osmosis, but with Selenium. So it was actually doing the UI. I didn't know about like how to get proper data. So I just made the bot that clicked the UI, checked all the prices, and then calculated the difference of measurement.
That's
and
pretty
I
cool.
made some money for it.
Incredible.
But not big money.
Mm-hmm.
I respect that. That's cool.
Yeah.
Yeah.
Yes. So I found out this paper about cyclic arbitrage.
Yeah.
So I just implemented in the TypeScript you know, a few months ago when the script actually started on Juno. So that was my way and my first interaction with this project. And somehow it works still, it works, but yeah, it's definitely not life changing, not even. Yeah, it's just like side small money.
Oh, cool.
I mean, it's really nice. I just take it as a nice, nice way to get into the DeFi world for programmers who are not. I have no experience in traditional finance. I don't know the products in traditional finance, so it was quite difficult to get my way into this DeFi world. And this is really something that might be interesting for anyone who's programming, because it's all about algorithms, right?
Yeah. So yeah, cyclic arbitrage is one of the most common MEV types. And it's basically the idea that, like if I make a big trade in a pool, let's say on osmosis, that it will unbalance that price relative to other pools. So you can actually you can trade an asset out of that pool to a bunch of different ones. It's cyclic, so it ends up in the same pool and you end up, or you end up in the same asset and you end up with more than you started with. So just to show a couple numbers about this, since we've done a lot of research here. This is cyclic arbitrage on osmosis over the last 2 years. So this is an interactive graph. If you want to pull it up, it's satellite.skip.money. But over the last, since osmosis started, basically, there's been $7 million of cyclic arbitrage that's been extracted. Maybe you were responsible for some of it? No? Okay, never mind. Today, it's basically nothing. Like today was $1, and I'll explain why. Skip is to blame here. But as you can see, it ramped up really quickly during the bull, and then it went vertical for 2 days straight. Anybody guess what that was? May last year? Terra collapse, yep. So whenever there is a collapse or major volatility, MEV goes through the roof. I remember the only bullish tweet I saw a year ago I was at a Terra hacker house when Terra was collapsing during the hacker house. So when Skip Got Started was at a Terra hacker house. And I saw a tweet which was like, what a day for MEV. And I just thought to myself, like, wow, what a shit thing to say. But everyone is suffering. But those were those people. They made $2 million in 1 day. So there's a lot. It's sort of flatlined. And then one of the reasons that it's flatlined is because all of the money is being extracted into one single account right now, which is this one. This account, which seemingly just prints money every day, belongs to Skip. It is the ProtoRev account. ProtoRev is an in-protocol cyclic backrunner. So it basically has priority access to any kind of cyclic arbitrage opportunity, and it will find that opportunity, mint itself money, literally mint itself money, using flash minting, which means every Cosmos chain can mint any IBC asset that it wants in infinite amounts, as long as it burns it by the end of the transaction, like a flash loan. And so it mints itself money in a flash loan or flash mint, and then it will execute that arbitrage and make itself money. We don't take this money. This money belongs to Osmosis, of course. And so this is a module account that later will be distributed to governance. So that's sort of to explain why things have flatlined partially. But in terms of where,
Though, we're kind of expecting as there's additional kind of integration between chains, users want to do more cross-chain flows. There's going to be more opportunities for different types of MEV. I mean, relay MEV is something that we haven't really seen before, but we think is going to be a big part. There's also this notion of like a keeper system, which is quite common in Ethereum. If you squint at it, it looks a little bit like a relayer, and this is kind of like a baseline revenue stream for a lot of MEV searchers. Things like liquidations or kind of poking a contract to do some form of automation. And relayers today already have kind of all of the tools that they need to do this. They have something that looks at the chain to kind of understand what the state is, and they can read off and say, okay, well, I need to submit a packet here in order to claim this reward that like hooks this contract. So as you start to have more cross-chain automation, you're gonna see more and more of these types of things. So this is where we start to see like some of the relayers and searchers like becoming, merging with one another.
Yes. Also, just to talk about other chains, so somebody mentioned Juno. Sorry, what's your name?
Yeah.
Jan. Oh, are you Jan Fabio?
Yes, yes.
Oh, he's a sick searcher. So he's on the Discord a lot. We have a lot of respect for him. So cool. So like if you look at Juno, for example, these are people who are using Skip to extract MEV. Let's take a second to load. This is like, on the left is the number of bundles that we receive. So thank you, Jan, for your script sending us 100,000 bundles a day. This is the amount of money that's extracted. So like on a really good day, we get like 1,400 Juno, which at one point was worth $40 a Juno. I think now it's about 30 cents a Juno or 40 cents. Like recently it's been a little bit less, but still people are making a couple $100s a day. And this is only in terms of what the searchers are paying for inclusion. This is not what they're actually making. They're going to be making at a minimum that or more. You can see like down here, these are like the top bundles that have been mined. Jan, let me know if any of these are yours. One guy made, this was a big one I remember. This was like, something was collapsing. Honestly, I don't remember what it was. It might have been Hopper's Dex. But there was like 2,000 Juno extracted in one bundle. And then like just to quickly look at Terra, for example, it's been actually a little bit better recently. There's been a couple big things. I think there was a moment where Astroport was dumping a lot. By the way, also when things go up, things are good too, not just when they go down. There were some big bundles there recently that were actually quite recent, as you can see, like late May. Cool. And then just to explain like how Skip software works today, we have two products, but mainly we're focused on one right now during this presentation, which is called Skip Select, which basically is validators run a software that allows for searchers to submit bundles of transactions that they can pay for top of block atomic inclusion. So what that basically means is, if we just go back to these slides for a second, basically the traders will send like a bunch of transactions in a bundle to one of our pieces of infrastructure called the Sentinel. The Sentinel will look at all of those bundles, sometimes thousands of them at once. We'll run an auction over all of them to see who is paying the most, and then send the winning one to the validator and tell the validator, hey, put this at the top, right? So that means that the searcher can win the opportunity guaranteed and win the back run. So then the validator will put like the prioritized transactions at the top under any like oracles or whatever else, and then have standard transactions afterwards. So I'm gonna go a little bit through the setup of how to get started with a searching bot. But before I do that, any questions? Yeah.
Yeah. How does that account for like sandwich tags? It's like a flashback system, right?
It is similar to Flashbots, except doesn't allow for sandwich attacks.
Okay, but if you can put a block in the top of the transactions, you could, right?
Yes, you technically could, except Skip will prevent your prevent your bundle from going through. So
you analyze the block, the packet. What do you call it?
We analyze the bundle, yeah.
The
We look at when you submit it as a searcher, you have to sign your bundle.
Yeah.
So then you have to sign your bundle, but then also one of your transactions in the bundle will be yours too, if you're doing a back run or trying to do a sandwich. And so we look at the order of signatures. So we make sure that the first transaction is not signed by the signer of the bundle, but the second one is allowed to be. So if you try to submit your own transaction before someone else, we reject the bundle.
Okay.
Jan, have you ever gotten a sandwich through Skip's infrastructure?
Well, I've never tried.
Okay. Good response.
But what if you can pre-sign the transaction with a different address, right?
So, yes, but that would also not be allowed. You have to, so like let's say you signed a bundle of two signers that was not you,
Yeah,
that would be optimistically disallowed. We're like very strict about it.
okay.
Like there's many bundles that probably are not sandwiches that we don't allow anyway.
Yeah, yeah.
But what it does allow for is basically cyclical arbitrage. Yeah, and you can use flash loans. White Whale has flash loans on a couple of these chains. Yeah.
You mentioned that MEV is especially like attractive where, or like there's a lot of MEV to be attracted when things are going south or north, right? Is that just because transaction volume goes up, or can you elaborate a little bit why that's the case?
It's usually because there's a lot of arbitrage. So like when there's a major price movement, either north or south, then oftentimes it will first take place in a localized setting. But then usually because it's blockchain, you know, that price is represented many other places. And so it will prevent a short-term arbitrage opportunity.
Okay.
So for example, when UST was dumping down to zero, it was mainly on Terra. But what was happening on Osmosis was UST was paired against all these other pools. And so people were arbing the shit out of that thing, right? They were like buying it on UST as it was dumping on Terra and then selling it on the pools where it was higher priced. Right.
Thank you.
Yeah.
Just to like build a little bit of intuition around this, MEV is generated from block space contention because you're trying to selectively insert transactions in a particular place in the block. So whenever there's a rapid price movement up or down, or there's an event that occurs like at a specific block, so like an NFT mint or something like that, that's going to generate contention. It's like, okay, I need to get in the mint in this block, and I want to be the first one in this mint. Or Luna, Luna just dumped like 50%, and it's just absolute cliff right now. Now there's a time sensitivity that the searchers are going to try to capture. But if there's no contention, even if there's a large opportunity, if no one sees it and there's no contention, then you can just submit and you'll win the auction. You don't have to actually bid that up.
Thank you.
Any other questions? Yeah.
If there are multiple bundles, is there still only one auction winner? If they're separate bundles?
Right now there is. We have done some work to make it so that there can be multiple winners. It gets more complicated with multiple winners because then you can actually you can trick us into doing a sandwich, so we have to be very careful about it. Because you could be like, oh, this is just a bundle that is totally separate, that's just for the top, and then this is a back run, but together they make a sandwich, right? Even though they individually look like separate bundles. So we've kept it to one for now because that's like, let's be real, like most of the opportunity. These chains aren't, Ethereum. But in the future, I think we'll expand it.
And I don't know who's familiar with the Cosmos transaction format, but Cosmos has multi-messages, so you can insert multiple transactions into a single, or multiple messages into a single transaction. And then that transaction can be bundled with the background, so that's something that's not available in Ethereum. But it's just like multiple searchers trying to do to hit the same block. Right now, there's only one searcher that will win.
What's the volume of today's cross-chain MEV on Cosmos?
Like MEV on each individual chain?
No,
all
cross-chain, so a swap that
cross-chain.
goes across a relayer, swaps one side, swaps the other side.
Minimal. So with cross-chain MEV, a lot of it takes place between the decentralized exchange and then the centralized exchange.
Okay.
A lot of it does that because most price discovery happens either on Osmosis pretty much or on centralized exchanges.
Yeah.
We see relatively little like cross-domain MEV where the two domains are separate chains. But there is some, I think, and I think White Whale, who's a great team, was also very involved in MEV searching, and they have their own bot, by the way, which is really good. It's open source. They have started to experiment with this stuff too.
Mag mentioned price discovery, like this is a super important factor. So one thing that we're excited about is more price discovery happening on Cosmos chains. So right now, really the only like meaningful price discovery that's happening on a DEX in Cosmos is like the Osmo price. There's liquidity there, and the Osmo pools are like those are actually the deepest pools of liquidity. And as more of these launches happen and kind of form the primary market on chain, you might start to see more cross-chain decentralized exchange interactions.
Maybe a basic question, but why is it better to have pools with higher liquidity than if you have like typical payment university where you have like low liquidity, you can get easily the disbalance between like the cyclic. Why is it better with higher?
Yeah, so like, why is it better to have a couple pools with big liquidity versus like a lot of little ones that you just know are gonna get arbed?
Yeah.
Well, I mean, like higher liquidity, at least in like a balancer pool, will mean lower slippage for the user, right? And like, ideally you don't want, you know, if I'm trading 20 of a token, I don't want it to move that much, because if it does move and, you know, arbitrage takes place, I'm not, in some way, like I'm not seeing that revenue come back to me in the form of lower slippage. I'm seeing it being extracted by a different party, right? And so ideally you want to trade in a place with high liquidity, but there's many DEX designs that prevent this, right? Even in low liquidity pools, like concentrated liquidity, which will be coming out. And you know, there's many other ways, or like better routing, and I think a lot of those things will develop over time too, right? So for example, if you had a big trade, the best thing to do is probably split it up over many different pools versus just hammer one small one, right? So and all that stuff I think is going to be coming. At least to us.
These low liquidity pools are also paired with a highly liquid token. So that's also where the price discovery on that liquid token becomes important, even for these low liquidity assets.
Yeah.
I just had to circuit arbitrage start just great because of entry point, because of the atomicity, which I'm just referring to the IBC arbitraging, which is currently not possible there. So at least as far as I know, you cannot atomically swap money on one chain, send IBC message, so back on other chain. So it makes things much harder, because I saw in one of your slides that it's goal of the MEV layer you are developing to change this. Is it so?
It is IBC Go. Yeah, but it's not going to make atomic. Sorry. What? Oh, the goal.
Sorry, if it is a goal of the MEV layer to implement this atomically.
Yeah, so you get into this domain of statistical arbitrage. So the searcher is taking on risk, inventory risk. If they don't complete the cycle correctly, if someone front runs them on when they're trying to close the loop, then now they're kind of stuck with the bag. So you need to, when you're performing that type of arbitrage, you actually need to build that into your business model effectively. Okay, I think I'm going to get, I'm going to be unable to complete that loop 1 out of every 100 times, and so that's going to hurt my profitability. We have done a ton of exploration around atomicity between chains. It's very challenging. This is part of the Atom 2 paper that I wrote, was how to, one possibility for doing this. Something that we're still interested in, still exploring, but basically what we found out talking to a lot of people in the ecosystem is that we're not quite there yet in terms of the opportunities available and the kind of education in the ecosystem. So we're kind of slowly leveling people up and trying to focus on issues that chains care about and users care about. And we think that that can eventually lead to a more efficient MEV and more interesting dynamic MEV ecosystem over time.
Yeah, so the relayer MEV, the implementation we're doing is single chain. So it's like basically you as the relayer are relaying a packet, it's a swap, and then it will back run it atomically on that chain. It's like cyclical arbitrage on that chain, the same as usual. But yeah, if you keep saying cross-chain MEV or cross-chain atomicity enough times, you will raise a $10 million seed round. So be careful. Investors are very excited about this concept. It's very difficult. It requires liveness assumptions that are resting upon other chains. And, I think the only one who's really addressed this is like Typhon with like a Noma. So I would check that out if you're interested. Yeah.
If I understand correctly, what you just said was so you kind of listen to the packets that go to the relayer, and then you perform MEV on that. So it's not really in the mempool, that transaction, right? It's just in the relayer.
Yeah.
And then when you assume that it arrives, you do the backrunning.
Yeah, it's like you take the packet, you're like, oh, that's a swap. Then you add your cyclical arbitrage afterwards.
Yeah.
You turn that into a transaction, then you send it to the validator. And then you hope the validator doesn't mess with it.
Yeah, it's maybe just saying a word about how IBC works here. So basically what's happening is you're on chain A, a user from chain A submits a normal transaction to chain A, and it gets included in that block. And that what that does is the state of that transaction says, I want a relayer to forward my outgoing packet to chain B. And the relayer is watching this chain. The relayer software actually like reads the chain state and it's like, okay, I am now able to pick up this packet. I build a light client proof of the that says that this packet was in fact here at this height. I submit the packet along with the light client proof to the other side. That can just go through the normal mempool. You could have, if you're running your own validator, then you could just include it in a block as well. But so that is just a transaction type on chain B. They submit it to chain B, it gets included, and now the packet has been relayed. There is also an acknowledgement packet on some packet types, which is the opposite direction that allows helpful for a number of different functions, but this is also instrumental for the ICS 29 like fee payment system. We should probably do searching and stuff now.
Yeah. Okay. How much time do we have? About 30 minutes. So, I mean, I'm not going to go super deep into this, but so what Skip does is we create open source bots. I mean, we do a lot of things, but one of the things we do is we create open source bots that help you start searching. They're designed to be extremely easy, and they focus on cyclical arbitrage. So basically this idea of monitoring the mempool for transactions that you can use to extract profit by basically cycling through other pools. It doesn't involve front running or sandwiching, and so you're not wrecking the user. You're sort of taking advantage of the state of the world to extract some revenue. So to talk through Skipper, first of all, here it is. So it is open source. It's GitHub, Skip MEV Skipper. There's two repos in here. One is Skip Go and one is Skip Pi. Highly recommend using Skip Pi for the most part because it works on the chains where it's the most effective. And then basically, it is relatively plug and play for getting this set up. It can run in a Docker container. It can run locally if you wanted to. And then it has pre-programmed certain pools and certain dexes that it examines. So for example, on Juno, it looks at loop dex and Juno swap, and then I think also now Wind, I think so. And then on Terra, it looks at its local dexes as well. And it will basically, all you need to do is create an account, fund it, select the percentage that you're willing to pay, and then it will try to execute arbitrage opportunities. So going into like skipper.py for a second, Jeremy had some fun with this. But basically, like the quick start is downloading all the dependencies and then cloning the repo, going into it, installing all the requirements. You need to put your seed phrase in it. Don't worry, that doesn't get uploaded to us. And then basically funding an account. You can also run it inside Docker if you want to. One of the fastest ways to create or one of the ways to have your bot be fastest is to run it on your own node so that you have access to local mempool instead of querying an RPC, because that increases the delay in terms of where you receive transactions. It talks through here how it tries to make money. Basically, it does cyclical arbitrage. So let's say you have 3 pools, A through B, B to C, and C through A. Then it will basically execute a cyclical arbitrage where you end up with more of the same asset than you started with. And so it talks about what it does. It first of all looks for transactions that are unconfirmed, right? So these are mempool transactions. It will parse them. It looks at a swap, tries to find the reserve amounts. It will simulate the swap transaction on top of local state to figure out sort of like what the state change will be. See if it created any arbitrage opportunity, then execute the arbitrage, and then submit it to Skip and say, hey, I want this whole bundle to be included at the top, and then we'll include some kind of bid. I will say these are very competitive at this point. There's a lot of people who are doing this on Juno and then also on Terra. There's one guy who always bids like 1 cent higher than everyone else. I don't really know how it works. Searchers blamed us for it being us, but it's definitely not us, I promise. But sometimes people have run this and done extremely well, especially early days. And I still recommend it as a place to get started, and then you can expand pools from there and find more opportunity.
Yeah, one of the best ways to get started is obviously like kind of run this, kind of make sure that it works. It's going to be a little bit disappointing because you're gonna press go and then it's like not going to make you any money at all, because everybody's just completely like eked out every penny from it. But you should use it as a template, and the way to actually do searching effectively is look at a new project or a kind of unexplored area and try to understand the contracts or how the application works, and then build a system there. Like you want to kind of go out the frontier of where searching is happening and find new sources. This is why it's called searching. And just kind of like tinker around. That's really like the searching mindset.
Yeah, like finding new dexes, new pools, all that stuff can be added. But this is a good place to start. Skipper Go was built for Evmos and Injective, though Evmos and Injective we're building a new product for that's not this because they're too fast. That's one thing, is the longer the block time, the more MEV there is, and it's easier for everyone to work on it. But with really fast block times, like Say is going to be crazy. You need a different system for that. Any questions on this stuff? I don't want to go through like a whole setup process. I feel like that'll just be boring, but just want to introduce you to the repository. And yeah.
What's the performance difference between Skipper Go and Skipper Py? Python usually is slow. Quite a bit.
I think Skipper Go you can probably push harder. I think usually it's not the performance of the code that is the issue. It's how many pools you have, and also how fast and how many transactions you can monitor. So that's what I was saying. Like one of the biggest performance upgrades here is you can run your own node, and then you can run, for example, Skipper Go easily on top of that because everything in Cosmos is Go, right?
Yeah, right. But if you select a lot of pools and your code is not like after the simulation, so the result of a transaction you find in the mempool, you try for all the pools to find the best pool to backrun it through, right?
Mm-hmm.
But if your selection of those pools is very wide, that will be computationally intensive.
Yes.
So that's why I'm asking, like, is there a difference between the Go and Py performance? Because I assume that will be like quite significant, but maybe it's not.
Yeah, that's a good question. I mean, I guess you could sort of get into like if you wanted to thread it. on Python versus if you want to like run a bunch of Go routines on Go,
Yeah.
and like seeing how that works out. I mean, if I don't know if people have pushed it that hard to do that many, because there's not that many pools, at least on some of these chains. But also, like, one thing to note is, for example, for ProtoRev, where all this happens in protocol, what we did was we just selected the pools and the routes that are like 80 to 85% of the MEV, and then we ignored the others just for computational reasons.
Yeah.
Yeah, so I think you can be like a little bit heuristically driven about it.
Yeah, if you look at the flame plot or whatever of like what, you know, the different timing of the segments of an MEV life cycle, like networking is actually probably going to be the largest one. Just I don't know that, you know, the numbers offhand, but if you're going to put like a lot of time into optimization, like you'd actually likely start there. Geolocating nodes, just kind of configuring like your interaction with the actual transaction and extraction and like submission process.
Right.
The code that's running on your computer is actually like negligible in comparison. So yeah, you want to kind of like prioritize where you're spending your time.
Yeah, like it takes about 200 milliseconds to pull down a transaction from a node. It takes negligible time to simulate this stuff. It takes about 200 milliseconds to get it to the Sentinel, and then it takes about 400 milliseconds to get it from the Sentinel to the validator. So it's like already you're like 3x the say block time right by that point. So like that's why it doesn't work. But on chains where it's like six seconds, it's good.
What if you skip the Sentinel? Like you submit it right to the validator?
You will have a tough time finding the validator IPs unless Imperator wants to share its private IP with everyone. But even if you did, you would not be able to get it at the top of the block because somebody who submits it later will use skip and get it at the top. Yeah, hence skip. Okay. Goes to the top. Yeah.
So does this bot also use these flash loans you mentioned?
So ours doesn't use flash loans, but White Whale has one that does use their flash loans and skip. And that one is great. Yeah, highly recommend that one.
Is there a main difference between the Skipper P and White Whale bot, basically? Like path searching or more or less the same?
I kind of think their bot uses a couple more pools or pools in a different way, and it also uses their native flash loans. So for example, theirs would be more capital efficient.
Yeah, I mean, the kind of objective of the projects is a little bit different. So when we're creating one of these bots, which we'll basically do this when we enter a new chain. And the idea is just to kind of like familiarize searchers for the first time with that whole flow. We just want to kind of like establish an initial base of competition, and very quickly it'll get outcompeted. So within the first week or whatever, like what we publish here is completely irrelevant, but it's important to like understand the interfaces and like how to interact with the system. White Whales, it is more sophisticated, that they'll actually like fork what we're doing sometimes, and they'll add their own, typically they'll come later because they want skip deployed on a chain before you can do like a flash loan system. And so
those are their docs.
It's really for the advanced user. So once you're starting to play with flash loans, like now you're leveling up a bit, but our skipper and who our kind of primary customer is our chains and validators. So we want to make sure that there's like that kind of baseline competition available.
Yeah.
So if I use the bot, do I basically just try to post to one specific validator that uses skip select? Or
great question.
Because otherwise, the thing that I haven't understood is because we're running round robin selection during block proposing. So right now in my head, I'm thinking that you basically always have you have to wait. If there were just one validator that has skip select, then I always have to wait until the block proposer is actually selected, the right one is selected. Right?
Yeah, that's a great question. So this is where skip comes in, right? So for example, you can check. If you go to skip.money, then you go to the validators, you can see all the validators that run Skip and how much money they've made for themselves and how much they give to the network. As a searcher, you don't have to worry about any of that. So you just submit it to Skip with the payment to one address, and then we figure out who's next. And so we'll either tell you, sorry, there's not a Skip validator next, and we won't take any money, right? And we won't put anything on chain, we'll just give it back to you. Or if there is a validator next, then you'll actually enter the auction. And so, I think now on, for example, Juno, we have 85% of stake weight. So only 15% of the time you won't get your bundle in, but 85% of the time you will. And then we'll handle that in the responses.
Makes sense.
Yeah. And then the nice thing about Skip is you only spend money if you make money, which means, well, unless you're an idiot, but you only will spend money if you get something mined on chain. Meaning if you just submit to the auction thousands of times with payments, it's not like you're actually paying for that. It only will ever take money from your account if you get something into the block, right? So it's atomic in that sense.
Even for when you do it without Skip, you have the failure fee, right? The gas fee of your failed transaction.
Takes all of your fees, yeah.
That's also not there.
Nope, nothing goes on chain if you don't win.
So the searcher bot is not making a transaction, it's basically like just sending an API request to register for.
Yeah, the searcher bot is sending basically a bundle of transactions. So let's just take a look at it quickly. So if we go to the Skip docs, you'll see you basically create this thing called sign bundle, and then send bundles, which is a bunch of transactions. And then we'll either tell you, sorry, you didn't win, or sorry, it's not there's not a validator that runs Skip next, or we'll put it on chain. Yeah. So you only pay for winning, which is nice. Wish everything was like that.
Yeah, I have another question. So right now in Cosmos, you don't really have the priority fee or any prioritization based on the fee per se, right? We have first in, first out. How does that interact with, I guess, or what's your view on that compared to the auction of the top positions?
Yeah, I mean, basically, this is going to change relatively soon. The reason that we have priority fee is kind of a historical accident of Tendermint, and I actually spent a lot of time at the ICF trying to make it possible not to have a first in, first out. With ABCI++, you can kind of do whatever you want. It's going to open up a lot of different possibilities. And what we are doing with our V2 version of our node software, instead of modifying Tendermint, we're now building a module called the Builder module. Oops. Sorry. And we're using all these fancy ABCI++ features. Sorry about that. And so we can do a priority mempool, we can do EIP 1559. Basically what we're doing, we have a really nice structure where we can kind of segment the block into different, what we call lanes. And each of those lanes can treat transactions differently. So they can only accept certain transaction types, or they can have kind of filtering mechanisms. So there could be an Oracle lane where only validators can submit to this lane. The transactions don't cost anything. And we're even experimenting with requiring that the validators include these transactions, or they get slashed, something like that. And then you could have a top block lane, and that would work just like the Sentinel software, the Skip V1, except it doesn't require any off-chain infrastructure. You just submit it directly to the mempool like you would any other traditional transaction. And then you could have an EIP 1559 lane that is kind of for low priority transactions like withdrawal staking rewards or something like that. And I mean, you can do lots and lots of crazy stuff. So we're even playing with being able to have certain transactions be free if you hold an NFT, or if you stake to a specific validator or something like that. There's a lot of experimentation that we're kind of thinking about and talking to different chains about. Yeah, the first in, first out is kind of like the old generation. Where we're going is a lot of sophistication. And we actually think that this is one of the main value props of Cosmos, period. Like, to be able to do this kind of deep integration of the application into the block space structure.
Yeah, so I mean, just to summarize, like what we showed you was Skip v1, where you have this off-chain infrastructure that you submitted to called the Sentinel. In Skip v2, everything happens in protocol. So what that means is we just deploy this module called POB into the chain, and then it's just the searchers interacting directly with the chain to submit their bundles. And then we did a lot of crazy shit basically inside of ABCI++ to make this possible with like all kinds of weird things. But ABCI++ lets the application take charge of their mempools in a way that you can structure it much differently.
I know everybody came here to talk about searching. Is there anything that people want to know about searching that we didn't talk about that would interest you?
So just out of curiosity, like, do you like monitor how effective is basically, for example, Juno or osmosis? Or osmosis, we see in the chat, but on Juno, for example, if you compare like what you do through Skip versus if you would not be using Skip, how is the competition, or how is it?
Yeah, so we did a little bit of, we posted a research article about Juno specifically. MEV since Skip launched has dramatically increased because a lot of people just didn't know how to do it. And also, it created a more efficient market where you can guarantee win things versus like probabilistically win things. But there were a lot of upset people too, because there were some searchers on all these chains before, and now they're getting wrecked because now there's like actually competition, right? But before they were always winning. But this is all relatively new profit. I think before Skip, Juno did a couple $1,000s of MEV over its lifetime, and now I think it's done, 32,000 Juno in terms of just pure profit from MEV that has been given back to the network and to validators to fund their operations. By the way, Skip doesn't take any money from this, any of it, except for the osmosis integration, which was custom. So it's, I think it's basically a new market.
Thank you.
And if you try to compete and you don't use Skip, you'll have a good shot if the validator is not running Skip, but if they are running Skip, you'll get wrecked. Yeah.
So if you are saying that you are not making any money on this, so what's your business model then?
It's a great question. Sam, any ideas? We don't take money on the MEV software that we deploy. Like, we give it 100% back to the validator, and then the validator gets to decide what they do with it. So for example, if you look at the validator list, Imperator is very nice. They give 99% of all their MEV rewards back to stakers. And they keep only 1%, which is the minimum percent allowed. Can't go down to 0. And then they also can configure their front-running protection, and everybody has it on.
Are you just avoiding the question?
Wait, I'm getting to it. So right now we give everything back. The way that we've traditionally monetized is oftentimes to deploy the software is like quite extensive. And so chains will give us some kind of like vesting grant to deploy, which recently has been a bad idea given the direction of token prices, but hopefully in the future will not be a bad idea. So for example, like right now we're going to announce it shortly, but like we're going to be like core contributors to the Osmosis protocol, because now the scope of our work has gone beyond just MEV and also into like block space design and some IBC things and cross-chain interoperability and stuff like that. And so we've been helping chains with a lot of different things, and this is part of what we do for them.
Yeah, so there's kind of this combination, like a service contract model for like special integrations. All of our software is free unless there's this like, you want something custom for your chain, and then we can kind of work with you to figure out how that would work, you know, whether you're gonna get wrecked if you build it this way or not. And we've gotten a bunch of interests in, in protocol oracles, some of these different lanes, things like that. We have lots of like fun ideas. If you're interested, you should talk to us. And then longer term, we think basically where this is going is most chains are going to kind of internalize a lot of their own MEV. We've already kind of seen this play out a little bit. Like they're going to eke out all of the efficiency that they can get. We think that there are some interesting directions in kind of cross-chain coordination and making it possible to run more efficient, arbitrage schemes between different chains. And this is one of the reasons that we're so focused on IBC UX. Is IBC is unusable right now. So there is no cross-chain MEV. Nobody wants to like do a cross-chain transaction. So we're just trying to like fix that and do the absolute basics, make sure that relayers work, make sure that wallets work, just make it so that you don't get stuck as a user. And then once we fix that, we think there's maybe a way to add value by creating these kind of sophisticated cross-chain flows or making them possible. And then we can potentially monetize something in there, but we're not 100% sure what it looks like just yet.
I don't know like exactly what to deal with Cosmos, but are you planning on opening models there as well, or is it like out of question because of like how you have the deal with Cosmos, right? Where you have this bot?
Yeah. So
is there gonna be like a relay am I gonna be like sending models on Cosmos?
yes, you will be able to.
Okay, thank you.
Give it like 3 months.
But
So POB is what is going to enable that. That
okay.
side.
So that's why you're moving to like core contributors and opening it?
Yes.
I see.
That's exactly right.
Thank you.
Yeah. We're going to try to move all chains that we can to POB because we think it's a superior model. Just runs on all the validators. It's in the protocol. Doesn't require off-chain infrastructure. And it's just more open and permissionless. And so we're going to try to move everybody to that. And then I think that's going to start on Osmosis and then probably also be hopefully Evmos, Kuno, some other places too.
Cool. Thank you.
Yeah. Oh, and Neutron. It is, so Skip Select is live on Neutron. I don't think Neutron is liquid yet, but once it is, people should create the first searching bot there. Should be a good opportunity. Could be a fun thing to work on at the Neutron Hacker House meeting.
So
They're cutting us off?
they're cutting us off. I am super happy with the turnout for a 9 a.m. workshop where we rugged every single person. Thank you all for coming. Mag and I are around all weekend, so come find us. We're happy to chat. I hope this was informative. Thank you all.